And we made it. Happy Thursday, folks. We're just about to finish off our third week so far. I have a good set of announcements that we're going to go through today so far to start us out. But probably the biggest announcement is, excuse me, I learned from a student in class, so thanks to that student for learning me. If you opted out of the ISU book bundle program, I believe possibly yesterday, but definitely by today, they restricted the access to the MyLab and the eText through Access Pearson, which is kind of rude. They want their payment for that, so it's kind of a jarring thing that happens. It should be presenting with a link to purchase the access. So for students that are in the book bundle program, you've already paid by being inside of that program. But some students have opted out, which is probably a good idea depending on which classes you're taking. You might save a lot of money by opting out of that program. And the free 2 weeks trial has expired at this point. I learned from the same student, so thank you again for that information, that you can re-register to get both the MyLab platform and the eText, it's 18 weeks access for $95. There might be another option, probably called multi-term access, where they might charge you like $150, but you shouldn't have to pay that much. So make sure you're paying the $95 for the single term access, and that you'll get you reinstated. Essentially, it's like paying for your electronic version of the book, the eText, and getting the homework system running again. And as far as the due dates go, the first due date for MyLab was, let's see here, January 28th for Unit 2A. So if you're locked out and worried about not being able to go in and complete that section, then don't worry too much. Once you get that reinstated, you can, in the way I've had set up MyLab, go back into any section, even if it's gone past due, and complete that section penalty free. So think of the due dates that I'm posting here as really just the overall pacing for the class. For getting through all the sections by the due date, you're considered fully caught up. And what I'll start doing starting this weekend is uploading the grades that I see in MyLab for all the assignments that you have been working on, the assignments that have gone past the due date. So you'll know what your MyLab grade is at any point. It will be uploaded here. It'll also be duplicated as well inside the system. After I grade quiz 1, I'll have this graded on Friday, sometime in the morning, possibly the afternoon. I'll go into the Canvas system and upload the annotated copy with any feedback, your score out of 10 points on that quiz. And then I'll go back here and upload your quiz grade. So the grades are going to start changing more and more now that the course is really getting going. I'll be getting in the habit of uploading what your grade is from MyLab on each Friday after I do the grading of the quizzes. And yeah, you're also allowed to turn in late work. So if you don't have quiz 1 done just yet, then no worries. You can still turn that in for full credit. So really, I'm only grading them on Friday. And same idea with the quizzes. I think these are really important documents to get through for the purpose of studying for upcoming exams. So if life got kind of away from you, you don't have quiz 1 completed just yet, I'll accept them for full credit as well. Other questions so far? Okay. Other bigger announcement is we're finishing off week 3. Week 4 is going to be another ordinary working week, except for on week 4, Thursday of that week 4, so a week away from today, is going to be kind of a special date for us, February 5th, because that's the point at which I'll start asking for questions for review that you might have in the course for the upcoming exam 1. So we'll do a review day before going into the next week for the exam 1 on Monday. Also, before you even come to week 4, I'm going to have the information loaded up in here of the exact sections that'll be on exam 1, as well as review problems that you should be aware of to have for further practice. Sorry, kind of a word salad there. I'll post the coverage and exam review problems in this before we even get into week 4. So we'll be talking a lot more about the exam 1 as we're getting closer to that date. Probably the good thing to do right now is make sure that you responded to the questionnaire that I sent out through the Canvas inbox of which your preferred campus is. Some people are on the Idaho Falls, Pocatello. Some people are going to test in Twin Falls, Meridian, and otherwise. Let me know and I'll get that organized as soon as possible so that Another thing that'll happen on Monday, the day we come back on week 4, I'll be individually emailing everyone in the class through the Canvas system, which also sends an email to your ISU email address with the exact instructions for contacting and scheduling your exam at your preferred testing center. Well, that's the announcement so far. It's going to be an ordinary week on week 3. We'll start reviewing on the last day of week 4, and our exam is still a ways away, but it's good to talk about this early. It'd be weird to only talk about exam 1 Thursday of week 4. But any other questions at the moment, folks, so far?
Yeah, Tammy had one, and I have the same question, so thank you, Tammy. Just can you go over the exams, the structure of them a little bit, as far as how many questions, what exactly they will cover, and the best method for studying for them?
Yeah, absolutely. That's a great set of questions. Since I'm reading this book for the first time and I'm writing my lecture notes for the very first time, the major goal for me is I don't want to get carried away and say overload the exam with too many questions. And there is a lot of content that we've covered from 2A, understand, solve, explain, unit analysis, problem solving hints. There's some kind of sketchy problems there. And now we're getting into percentages, so lots of different topics. So one thing about the exam writing is I can't ask every single question that came up on every single section. That's going to be like a 30 question exam, right? That's way too long. I'm going to go for an exam that's probably more along the lines of 10 to 12 questions. They're 75-minute exams, excuse me, 70-minute exams because our class is a 70-minute class. And so also what I'm going to be trying to do is not exactly write it for a 70-minute length so that you're writing the full 70 minutes. I'm going to write an exam that's going to be about a 50-minute exam altogether. That you can go at a reasonable pace, not feel like you're rushing, and get through all the problems with additional time at the very end to check your work. So I'm thinking I'm going to go for between 10 to 12 questions with the goal of not overloading the exam on the first one I write for this material. So I'll go through each one of these sections and just pick the problems that seem to represent the sections well, not getting carried away, probably 2 or 3 questions per section to round out the exam material. So that's the first part of the question of what is the exam going to look like? To really better address what is exam 1 going to look like, I'll be kind of conveying that when I post the exam review problems. That'll be my way of saying, here's what my exam questions look like. If you can solve this problem, expect similar types, maybe different numbers, different kind of concepts, the same kind of strategies to solve them. So let's see. Any questions so far as I go to the other element of that question?
No, that makes sense. So you will put up somewhat of a study guide beforehand, right?
I'm going to go for 2 versions actually. I want to have a version which it's going to be the lecture notes themselves. I'm going to convert them into essentially what they would look like as exam questions. So on a section by section basis, say for 2B, if a question does look like it'd be a reasonable exam question, I'll leave it on. For anything that has something like a table like this, I'm going to take it out. And if you need a unit conversion, I'll write that information in the problem. So there'll be information cited. So there's not going to be anything, say, like this on the notes when I convert this into a worksheet. It'll just be the information you need to solve the problem. And I might take some of the problems out. If I feel like some of these problems just don't feel like they worked great in this exam, they'll be deleted. So that'll be my way of conveying to you what does a real exam question look like. The downside to that, though, is it might feel like deja vu. You've seen all these problems before. So I'm going to write a second exam. My second exam is just going to be brand new problems that we haven't solved before. I'll have solutions at the very, very end so you can check your work as well. So there'll be 2 kinds of materials here for what the exam questions look like. They'll be a little bit longer because they're covering all bases, basically. The real exam is going to be shorter than what I post on either version of those sample exams. And the other statement to make is, how should I prepare for the exams? I'd say there's a definite great order of operations for preparing for any exam in this class. So let's just write it down just for quick reference. The first thing I would do is get caught up on all quizzes. So once you're caught up on those quizzes, sometimes with as far as these quizzes go, they're kind of my way to convey what does a real exam question look like for the material you've been going through. So if you get fully caught up on all quizzes, you'll have a great rounded view of some of the exam questions. I'm not assigning a quiz for every single section. It's a weekly quiz, but still getting through those is going to be really helpful, a great preparation. I'll have a third quiz posted here, so there'll be 3 quizzes to get caught up on. Second thing to do, it would be to get caught up on my lab assignments. I'll just say my lab for short. And I'm trying to write all the material in this course with a pretty high degree of parallelism. So I'm kind of starting from the ground up. I start by reading the book, see what it's all about. Then I go into my lab inside that system and I look into the questions that I can assign, and I assign what looks like reasonable based off what I read, what that section's all about. After I have signed those problems, I go to write the lecture notes based off the my lab problems. If I write a quiz problem, it's based off those lecture notes. And I have not written this exam yet, but once I start to write this exam, I'm going to review what we did in class, either in the lecture notes or as a quiz problem, or what you did on the MyLab homework. I'm going to make sure everything is in line, the same kind of questions, very similar wording, same level of difficulty. So if you're nailing these parts right here, not only are you getting a major amount of the credit as stated in the syllabus, I'm going to remind myself, I think that's 25% of the course, but my classes are all set up slightly different. Yeah, 25%, 15% for my lab, 10% for the quizzes. So that's worth more than the exam one all on its own. Getting these 2 nailed down is going to get you in a really great spot for knowing exactly what's going to come up on the exam. Then for step 3, look into the review problems. Posted. So those are going to be the problems I'll start working on this weekend. And my goal is, and I should be able to meet this goal, is to have the review problems posted down here before we even get into week 4. So if you're all caught up on parts 1 and part 2, you can start looking into these a little bit early. And that might be helpful to you since on Thursday, we'll be reviewing for exam 1. So the final thought to get prepared for the exam 1 is come on Thursday, February 5, prepared with targeted review questions. Whether it's a question on a quiz, a question from the MyLab homework, maybe a tough one that you saw, or a question from the review documents I'll posted, I'd like to make my review be student directed. So I'll call for questions directly from you. And if you've got great questions prepared that you all think are great ones for us to do to review, we'll start there. If we run out of student directed questions, I'll have some material as well that we'll review. So we're not going to just be kind of bored staring at each other. We'll review one way or another. But I'm going to start with the questions that you all have to begin the review. So this would be my big order of operations for preparing for any exam whatsoever, in particular, the first upcoming exam 1. Again, it's a ways away, Monday, week 5, but it's good to think about it now. Instead of feeling like we're blindsided about it, realizing, oh crap, we're on a weekend with an exam coming on Monday. Good to talk about it now, and we'll review on Thursday of this week. But other questions at the moment? Thanks for asking that one. Okay.
I don't have any more questions. That's all very well thought out. Thank you.
Yeah, you bet. I'm pretty much going to be duplicating again everything that we're seeing on the Canvas webpage, the way all the exams are going to run. It's just going to be repeated on a pretty much cyclic basis. So next week is going to look just like this. I'll reference the upcoming quiz that's about to be due. Oh, I guess I can't bring that back quite yet. There'll be a brand new quiz number 3. And every one of our exams are going to be set up in this kind of way. So for example, when we have President's Day coming up, that's kind of nice after the exam. But when we're down here, the upcoming exam two, we'll do it all over again. I'll start talking about what's coming up. We'll have a review on Thursday of week 9. But before we even get to week 9, the exam coverage, the review problems will be posted. And so this is just going to be a repeat on an exam 1, 2, 3, and even the final exam basis once we get to the very end. This will be a cumulative exam, but once you've gone through exams 1, exams 2, exams 3, my final exam is going to be based off all of that material. So we'll have a really great idea of what's really on the final exam at that point. Well, let's get back into where we left off. We're now in this section here, uses and abuses of percentages. I focus my lecture notes more on the uses of percentages, but the reading is pretty great on things that can go wrong. So that's why I have that full title there from the textbook. And we left off on doing some computations on percentages, just using this formula here. We want to write the following statements, expressing the first number as a percentage of the second number. So the last question we did was, we expressed the estimated 5,550 nuclear weapons that the USA holds as a percentage of the total amount of worldwide nuclear weapons, a very gross estimate, by taking the ratio, the first number divided by the second number, times 100, and we just throw in the unit to express it now as a percentage. So we're going to build off that and talk about growth and decrease in different kinds of contexts, looking into absolute change and relative change. So here's the big formula that we kind of just looked at, but we didn't quite get into, that we ended on last class. Well, to start off this question, it says, find both the absolute change and relative change as defined through these two different quantities. Relative change only, that one is a percentage, not both of them, in the following cases, and we'll round percents to the nearest tenth as needed. So we won't round the absolute change is what it's saying here. The absolute change we think of as some new value that's being given. Usually it's current data. But in our textbook, the current data is 2020, so 6 years old already, it looks like. So absolute change will be what we have currently, or the last most recent data, minus some reference value, which is usually in this textbook, in this section, going to be historical data. So data from an older date. So let's give these both a try. Keep in mind when it says relative change, this is the tie-in of the section. Really, we're just looking into a percentage more than anything. To start out, it says in part A, this is a problem that's kind of near and dear to my heart. I took a substantial amount of student loans when I was a student, undergraduate and graduate school. And we're told to start off the context in this problem. Total student loan debt in the United States increased from 1.06 trillion, this was in 2014, I was a student in that year, to 1.57 trillion in the year 2020. I don't know where it is right now, but that's a kind of an interesting question at this point. But let's answer the question as it's shown. That's a huge increase from 2014 to just 6 years later. And we can express that in a couple ways. We'll start with the absolute change. How much did it grow in absolute terms without a percentage? First thing we need is the new value. The new value is going to be the recent data. We're at 1.57 trillion in year 2020. So we'll just state 1.57. This has a unit, I forget. Money is special, dollar sign goes first. 1.57 trillion. The reference value is from the prior data, year 2014. It was up to 1.06 trillion. So the reference value is at 1.06 trillion. So now we're ready to calculate absolute change. Really, it's not too bad of an equation. Absolute change is just going to be the new value minus the reference. So here we'll say absolute change equals compute the new value minus 1.57 trillion. Forgot the unit again. 1.57 trillion minus 1.06 trillion. And I forgot that unit again. That's a tricky one for me, it turns out. And we just about have it. Maybe let's pause right here just for a moment because we were just talking about exams for quite a bit. As far as the units go, I'm trying to be as careful as possible when I'm writing them out on the lecture notes. And I encourage you to do the same when you're writing down your scratch work in MyLab, when you're doing a quiz problem, and even when you're doing an exam problem. But I have one weird constraint in this class where the bulk of the homework is in MyLab, and MyLab often just prints out those units for us. It's not part of the question, the number is. So if MyLab prints all the units in the bulk, almost every single question, it means I can't really grade on units. I'm not going to be really picky if you drop the unit, you have the right numerical value. But I still encourage you to get in the habit of writing them out because, as we'll see in this section and in the next section, writing out those units can really tell you if you have the right number in the very first place that you're multiplying together. So always try to be as careful as possible with units. If you left them off in an exam problem or a quiz problem, you're not going to lose credit because the homework isn't really emphasizing it when it assesses the problems that you do. But let's throw this into the calculator. Oh, let's clear all that stuff off. I teach a class that goes to 6:45 on Thursdays only, so sometimes there's a bit of a residue from that last class. Let's resize that. And 1.57, this one's not too bad, but when you're tired, arithmetic is the first thing to go. So to be careful, I got 0.51 trillion as the absolute change. So that's one down. Next to go is relative change. Any questions at all, folks, with the first part of that computation? Okay, so now for the new thing, when we say relative change, we're thinking in terms of percentages. Sometimes it's hard to appreciate the size of that number. I mean, 50.51 trillion is a lot, a $500 billion and some change. But if you can put it into a context of relative change, a percent change from the reference value itself, sometimes the number has a lot more meaning. So that's our new computation. Do the relative change. Now we're thinking in terms of percent. And the formula is kind of structured in a nice way. Notice the numerator for relative change is what you just calculated, absolute change. You just divide it by the reference value. So if we duplicate this entire line before computation, it'll be $1.57, not $1.57, 1.57 trillion. And, I noticed that it's probably good to say here, I got the unit trillion on the end line there, and I was just talking about being careful with units. I should have said on the end of both of these, trillion. Let me squeeze it in with the arrow. Sorry for that omission there. This is not $1.57. This is 1.57 trillion minus 1.06 trillion in dollars. So there's the reference value. And the whole thing is divided by the reference value once again, 1.06 trillion in dollars. Okay, so there's the whole thing. We convert it to a percentage by taking this operation, go times 100%. So now all we'll do is throw this into the calculator. The unit that we save is just a percent symbol. So being careful with units is just a reminder that the trillion cancels, the dollar sign cancels. We're just looking into the numbers, the absolute change divided by the reference value. Well, in the calculator, here's what it looks like, finally. If you're working this out in a calculator, one where you can type in more than one statement all in one line, see like that, say like the TI-32X2S, that calculator we often show in the screenshots that we were looking at last class, It's not a bad idea to put in parentheses around the numerator like this to start it out. Because the next computation is just a matter of divide by the reference value, 1.06. So you can just build off what you already had in your calculator and then go times 100%. So that gives us the figure 48.1. Let's see, that's to the nearest tenth of a percent equals 48.1%. And we did it. That's our relative change on this problem. So if we were to say this out loud in just ordinary words, we would say that the student loan debt has increased by 51 trillion from year 2014 to year 2020. But this tells us finally that this represents a growth of 48.1% of the 2014 value. That might not be bad to put down in paper just as a reminder what this number means in context. We can say the student loan debt increased by 48.1% in 2020 from its 2014 level. Again, that's a startling increase. $51.51 trillion is a lot, but that's almost increasing by half from the prior value, only 6 years prior. Well, that's what's going on with both absolute and relative change. Any questions with either one of those computations so far?
There is a question in the chat.
Oh, sorry for missing that. Oh, weird. Something's going weird with my chat. I did get the red dot notification I'm used to seeing. Zach says, is there a good shorthand for trillion, or do we have to write that out when we see it? You know, a great shorthand would have been just an ordinary T would do the job. If I put a T here, that's a good way to just indicate trillion. You know, that kind of might have slightly saved my unit omission here if I threw in a T minus 1.06 T to stand for trillion. And where would that come from? I think it's good to see it in these terms right here. It comes back to this section 2B unit analysis on the prefixes and the suffixes. I said that backwards. Prefixes and the suffixes here. No, I said it wrong. Prefixes and prefixes for the larger values and the smaller values. T will stand for trillion in just about any kind of context. Other questions so far? Okay, I'm going to leave my chat up since I seem to be missing statements in the chat. Sorry about that. I think what happened was I left my entire Zoom session open when my last class ended at 5:45. So probably should close that out and then reopen it to eliminate any kind of weird behaviors on Zoom. Any other questions at the moment? Okay, well, next problem is a similar kind of scenario. We're looking into the number of AM radio stations in the United States. We're told it decreased from 4,978 in 1990 to 4,560 in year 2020. And this is kind of relevant in the sense that I've heard in the news somewhere, some new car makers aren't even putting in AM radio tuners into their cars whatsoever any longer. So that's kind of crazy and startling in a certain sense. But it might be from this kind of view. The number of AM radio stations is small, and it looks like it's going down. So let's do the same problem on this one. We want to calculate both absolute and relative change. And this will be a good one to try out on our own for the class. So let's make this a question we'll take a few minutes on. Grab a piece of paper and pen, and let's say in 3 minutes, so 6:33 should do the job. We'll compare our answers on this one and see how it comes together. So I'll give quiet. Let's all give this one a try. Okay, it looks like we're about at that 3-minute mark. Any volunteers for either the absolute or relative or both? Either over voice or chat is fine.
So for the absolute change, it would be negative 418. So it'd be 418 less radio stations in 2020 than 1990.
Yeah, absolutely. And thanks for the interpretation as well. So negative 418 altogether. Any volunteers for the relative change?
For the relative change, it would be negative 8.4%. So it would, the number of radio station, AM radio stations is negative 8.4% less in 2020 than 1990.
Yeah, exactly. Thanks for both of those values, Amy. So yeah, that's actually exactly what these come out as, and great interpretations. Just for a quick sketch on getting both of them, this one was found by taking 4560 stations minus 4978 stations. And then this value was doing those same exact steps. So 4560 stations minus the 4978 stations. And then the key step on doing the relative change is you just divide by that same reference number. So you see a matchup here to here from numerator to denominator. So I'll put down below 4978 stations. Take the whole thing and go times 100%, and then that's our value. So we got it, folks. Negative 418 stations is telling us, as Amy said, the number of radio stations decreased by 418 from 1990 into 2020. And the percent seemed to be the superstar. So let's write out a statement for that one, emphasizing the relative change. We can say from 1990, 418 stations really seems like quite a lot when you see just the absolute raw number there. It seems like we're losing quite a bit. But actually, it is going down, but that's not a ton. It's not like we lost 70% of all radio stations. It was less than 10%. Still kind of a problem. Probably why car manufacturers are leery about putting in an AM radio tuner. So say from 1990 to year 2020, the number of radio stations decreased by 8.4%. I notice I didn't put a negative on that because if we say decreased by, that's already implying the negative in the problem already. So we can now just cite the positive 8.4, imply the negative by giving the direction and wording in that way. We did it, folks. That's absolute change and relative change in a nutshell with these scenarios. Any questions or comments about either problem? Okay, and I guess this has been uses of percentages so far, but we'll look into a little bit about the abuses of percentages. The book goes into a lot of extra detail here, but sometimes percentages get really, really confusing if you're talking about relative change and the numbers in question are percentages themselves. Things start to get vague and foggy. So that's what's going on with this little bit of guidance right here. Percentage points versus, let me fix the supposed grammatical issue here. There we go. Percentage points versus using a percent symbol can cause major distractions. So our author gave us some advice on navigating these issues. It says when discussing changes between numbers that are themselves percentages, avoid miscommunication or ambiguity by doing the following. If you're talking about the absolute change from one percentage to another, it's a good idea to use the word percentage points. And if you watch the news a lot, you've probably heard this often. Oftentimes, if they're citing growth of something or decrease of something, they might say the size of the economy increased by 3 percentage points in the first quarter, something along those lines. Who knows what they're talking about? But if relative change comes up, the topic we were just looking into, in that case, we should use a percentage sign to convey the same numbers. So again, to me, this is where percentages get kind of tricky. And here's a couple examples, example 4 and example 5, that's going to look into this. So example 4 is this kind of a vague scenario where they say, over the last 5 years, the percentage of small businesses that report high energy costs as their primary concern increased from 18% to 27%. We're going to do as before, find the absolute change and sorry, I forgot I separated it into 2 questions. We're going to find the absolute change and relative change. I thought I missed something there. In terms of a percentage, we'll describe part A in a percentage points. So to organize this, we still want to think in terms of the new value versus the reference value. So trickiest thing about this one is, what is the new value? It's talking over the last 5 years. It says it increased from 18% to 27%. That means if we follow time starting off from 5 years ago to present, this would have been the new value, the 27%. So just organizing the information presented into the quantities we need in our formula, sometimes that's kind of a challenge as well in the context. So the reference value, the old data, is going to be that 18% we see here. So now we're doing this one into just segments. Part A is going to be the absolute change. The absolute change is not too bad. We'll say absolute change is this. Always the new value minus the reference value. So we'll take the 27%. Subtract from that the reference value of 18%. And we get altogether, let's see, 9% is the absolute change. But it said, you know, probably a good idea when it comes to absolute change, and I just completely ignored those instructions, it might be a good idea to not write that unit and just convey it as percentage points. If you did put a percent on here, I'm not going to be super picky because the MyLab homework exercises, once again, just completes the units for us. Oftentimes we don't get an option, it just tells us what it is. But we'll see in a moment why probably this is a good idea. Just call it 9 percentage points. Because if I say the absolute increase is 9%, that might not sound like a lot. But you know, that's a lot, going from 18% to 27%. If we describe it in relative change instead, we'll get a better feel for the actual impact and magnitude of that increase we see there. Well, any questions first, folks, with the absolute change at the moment? Okay, well, it turns out an absolute change of 9 percentage points is a lot in terms of the relative change. The percent change of these percents changing right here is substantial. Half of 18% is 9%. So if you add 9% to this, you get 27%. That's a 50% increase. But you know, let's navigate it through the formulas. The formula for relative change, let's cite it just for reference. relative change in this problem, and in all problems goes through this formula, new value minus the reference value divide by the reference value and multiply by 100%. We'll write this one in terms of a percentage using the actual percent sign, since we're now thinking relative change in this problem. Well, for plugging in the numbers, it looks a little bit weird at first. Here's what it looks like. When we plug in the new value to start, we put in 27 with the unit. This is a percent this time. Subtract the reference value, which is 18%. And we think of that as a bona fide unit. Down in the denominator, it's 18% as well. Then multiply by 100%. There's lots of percent symbols out of nowhere on this problem. But in this configuration, the percent symbols will in fact cancel out. So we have a raw number here that we're converting into a percentage and just keeping this one percentage symbol. Let me hide that problem down below. Sorry, just trying to get this all in view. So now when we go to throw this into the calculator, here's where what we're going to get. We had the 9% of the numerator. If you're typing this all in one line, don't forget to first put parentheses around the numerator, or else we might get a strange value. So go 27 minus 18, close that parenthesis, divide by 18. So that's the percentage as a decimal. We turn it into an actual percentage by going times 100. And that's the increase, 50%. It's kind of shocking. And again, when you're hearing stuff in the news, sometimes people are trying to convey an angle or some kind of narrative. Maybe they're trying to minimize or maximize the impact of something that happened in an economy sector or otherwise. They might say something increased by 9 percentage points. So in other words, over the last 5 years, the percentage of small business owners that reported high energy costs as their primary concern, it increased in absolute change by 9 percentage points. You might say, well, that's tragic. That's not great. That means a lot of a bigger burden on these business owners. But 9% doesn't feel like a lot, just like decreasing by 8.4% didn't feel like a lot here. But that's not the case. We were talking about 9 percentage points going from 18 to 27. That's a 50% increase. That feels more like panic rather than unfortunate, but not the worst news in the world you've ever heard. Whereas if they reported over the last 5 years, the percentage of small businesses that reported high energy costs as their primary concern increased by 50%, we can see that that sector of the economy is not happy. They're having just really bad year or last quarter, something along those lines. So the way we convey these numbers really matters a lot. Saying percentage points is just talking about the relative change, either growth or decrease. But putting it back into context to feel the magnitude of that growth and increase is the relative change. And here's where we would use the percent symbol in this context. Well, any last questions at all, folks, thinking about this new verbiage and this new guidance of thinking about percents? Okay, let's try this out again to see how it goes. Just double checking I didn't miss a chat or anything by refreshing it. This will be the last problem that we'll do in this section notes. It doesn't feel as like random context. That one didn't have the best, most immediate relatable context. We just said small business owners. But this one looks like it's real data for USA. We're told that the percentage of the world's cars manufactured in the United States decreased from 23% in the year 1999 to 12% in the year 2019. So like before, we can organize by seeing what is the role of each of these values. The new value, well, the most recent data we have is 12% in 2019. So that's going to be the new value. In terms of the reference value, that's going to be the more historical data in 1999. So here's the reference. Some of my letters aren't rounding out the way I want. There we go. So if we're talking about just absolute change, we'll mention it in percentage points to just say it went up or went down by however many percentage points. So absolute change. If you want to abbreviate it, absolute is a great way to just say absolute, ABS dot. Absolute change is going to be the new value. We always take this quantity first. 12% minus the reference value, 23%. And then this will be altogether negative 11%. So the order matters. We're told that it has decreased, and we're seeing the decrease down here by conveying it with a negative percentage sign. So we could say, just as a overall wrap up, this is our last problem, so let's put just a different way to conceptualize this. From 1999 to 2019, the percentage of the world's cars manufactured in USA, we'll say here decreased by, just to convey the direction, the negative sign. And I noticed I made a mistake right here, even though I had it highlighted. Let me fix that. I wouldn't consider that something that could lose you points on any quiz or an exam, but it could definitely give us a misconstrued idea. Let me say negative 11 percentage points. So we can compare the interpretation we're going to get on the next part B, and also to never convey any kind of miscommunication. We're just saying literally down by 11%, but that's not the relative change whatsoever. We emphasize that by saying percentage points on this one. So we'll say decreased by 11 percentage points. Now, what part B tries to do is look into, well, how big is that magnitude? If USA was, say, manufacturing 80% of the world's cars, decreasing by 11 percentage points down to 69%, sure, that's not great, but that does not have the same impact as it does if the reference value is 23 going down to 12. That's a completely different kind of relative change. So that's what we're going to address in that part C, the actual relative change in the problem, to really see the impact of the change from 1993 to 2019. But any questions first, folks, with part A or the interpretation below? Okay, so for the last computation, relative change is going to be the difference of, in the numerator, the same absolute change. So you can either copy this in. I think this is good for the notes just to convey how it's computed from scratch. But if all you put down here in your work is negative 11 with the percent symbol, that would be okay. Using a percent symbol because our denominator is now the 23%. But then we take times 100%, cancel the units. Percentage in that fraction completely annihilates each other. And we'll have, let's consult the oracle here. 12 minus 23, divide by 23. times 100 is negative 47.8. Let me double check the rounding on this one. Nearest tenth, so negative 47.8%. Again, that's pretty huge. If we kind of misrepresent these data and we never said the original numbers, and we just straight out told people that the percentage of the world's cars manufactured in the United States is down 11%. Well, that doesn't have the same impact as this statement does. So that's why it's a good call in this case. If the numbers in question are percentages themselves, say it's down 11 percentage points. So now we can say this statement. In 2019, the percent of all cars manufactured, I must be getting tired of misspelling things, manufactured in, let's say, by USA fell by 47.8% from the 1999 level. Well, that's one way to convey this as a statement. I think you might have a different way you might say it. If everyone put this in their own words, it might come out slightly different. If I tried again, I might say from 1999, the United States to the year 2019, the United States produced 47.8% less cars than all the other car manufacturers on the planet. Here I just said all cars manufactured. But again, that number has a humongous impact. If you're trying to hide that impact, we might have just said down by 11%. But that doesn't really convey the whole story. The relative change is down by almost 50%. We can kind of see that if we see the numbers from here to here. But this really emphasizes it. Well, that's the complete rundown of working with percentages in Unit 3A. We'll take a lot of these ideas as we bring it over into the next unit, 3B, putting numbers into context. But any last questions or thoughts, folks, on finalizing this section? Okay, well, we've got a good amount of time, just under 14 minutes. So I don't want to go too far into the next unit notes, but let's take a look at it, see what we're getting into, and maybe start the first problem to see how they go. So Unit 3B, again, everything is kind of in flux on Canvas. You might notice that things sort of move around. When you come back next week, I guess for today, we're moving it. I like to move things, oh, where to go? I like to move things to where they are going to land, where we finish the actual section notes. So 3B is going to be down here when you come back next week. Since we're only starting it today, it'll be finished next Monday. So let me pull up those notes. This is titled Putting Numbers into Perspective. And so you kind of notice a pattern to this class. For just about every section that we start, there's some kind of mathematical review topic that's extremely pertinent to what we're about to do. Like the prior sections were things about exponential notations, specifically with powers of 10. Now we're looping back on that and talking about scientific notation. This will be useful for a couple areas in this section notes. Well, we're going to start with just some context-less math problems, getting comfortable with scientific notation. Then we'll use these skills in some problems like these, expressing $2.8 trillion in scientific notation, or the diameter of a hepatitis C virus. Another surprising kind of problems we'll solve here is kind of random to start, like could an average person lift the weight of $200 in nickels versus the number of breaths a person takes in a year, we'll use scientific notation as it comes up in all these kind of problems in these kind of contexts. This one looks like about energy produced from nuclear fusion versus the burning of coal. So to get comfortable with those topics, we'll first just practice scientific notation, which is kind of a great review for this section. Really, this has came up already, really, because scientific notation was part of what was going on in, oh, I might have closed that window. It was what was going on in Unit 3B when we were looking into this table here. Should not have closed that window, but we're dealing with scientific notation essentially when we were looking into these prefix values for small quantities versus the large quantities as well. So we're returning to this information. This table is still going to be useful, as well as this table here, the conversion table. So starting off this question, let's look through the definition and precisely navigate through it. We'll say a number is in scientific notation if it's in a format in which we have a first number expressed as a number between 1 and 10 that gets multiplied by a power of 10. So if we match those two components, we're now in scientific notation. So a good practice problem to start this topic off is just writing things down in scientific notation. We'll think about how to do this first by hand, but keep in mind, calculators are open in this course, and they're encouraged on homework quizzes and exams. So there's no harm in double checking your intuition just by running it through a fast computation down here as well. So 8,200 is not too big of a number, but this one's pretty extreme in its smallness, this 0.00416. To get the first number in scientific notation, we have to first come up with a number that's between 1 and 10, and then we'll multiply it by a power of 10. Anyone see which number we would put down between 1 and 10 to start it off? Sorry, say again, Zach. You came in just kind of thing.
Yeah, I was gonna say, would it just be the amount of numbers that are in the number itself? So 4.
Not quite. It's going to be a different number based off the digits that you see here, rather. But the power of 10 could be something along the lines of 2, 3, 4. So you're on the right track for that portion right here. So we'll start off by saying some number that's going to be between 1 and 10, and then we'll multiply it by 10 to some exponent power. But anyone see what the number should be that goes in front? Yeah, absolutely. Both Echo and Brianna say it'll be at 8.2. So that came from the original number that we saw here. Essentially, we just put a decimal place right there between the 8 and the 2. And double checking, yeah, 8.2 fits. It's between 1 and 10, so it's in that right range. Echo also said that this should be to a power 2. And again, there's a couple ways to think about this. There's no harm in just double checking. If we go 8.2 times 10 to the power 2, we get 820, but we're off by just 1 order of magnitude. So we're pretty close on this one. We have to bump the power to something else. Anyone see what the right power should be?
Power of 3.
Yeah, if we bump this up to 3, calculator will output 8,200, the original number format. And so this one will be power 3. But again, there's lots of ways to think about this. So let's look at this again. 8,200 had a decimal point that was truly right here. It was 8,200.0. But when we went to satisfy this requirement to make it a number between 1 and 10, let me take that comma out, we are shifting the decimal point 3 units in the direction to the left. We made it really small as a number when we turned it into 8.2. So the number really isn't that small, so we bring it back to its true size in order of magnitude by multiplying 10 to the power of If you went left 3 units, you go, let's say it this way, 3 units left, which means we put power 3 here, or another way to say it, go up 3, or I don't know if up is the best way to say it. Let's say go positive 3 for this value here. So that's another way to think about scientific notation. You make the number small to start, and so you multiply by a large value of, or a high multiple of 10. Maybe it's powered 1 potentially, but more likely 3, 4, 5, and so on. So that's our first look at scientific notation. And again, we're going to be pretty experts at working our calculators, so there's no harm in double checking it in this format as well to see if the numbers just line up right. And sometimes counting these 0 or these places you move, that can be a lot of work for your mind's eye if you have, like, say, 13 different decimal places you're trying to track. So it's good to give an independent verification down here as well. Well, that's one direction it can go, but notice the annoying thing about this. Going left is towards the negative numbers, but we actually put in a positive value for 10. So there is a mismatch. There's a cross wire when you're doing this. There's an opposed directionality. Let's do one more. This one's kind of in the opposite direction to see how this one will go. We'll look at it from both sides, from the calculator verification, as well as from the standard way to think about it, just moving a decimal point. So we start off with a very, very tiny number, but we need to come up with a number between 1 and 10. It'll be multiplied by some power of 10. So filling in the blanks is essentially how we're thinking about this one. Any volunteers for the number that will go in front?
4.16.
Yeah, good call. We take that decimal point and we move it right there. Why didn't we go here? Let's put down some misadventures first, and then we'll look at the point 4.16. Well, rather, let's just put it in, just as it should be, 4.16. But the additional comment was we didn't go 0.416, not because it's wrong. We could put in the right power 10 for that, but it's smaller than 1. We have to be between those bounds, so we couldn't do that. And we can't go 41.6 times the power 10. Again, not because it might be incorrect. You could put in the right power of 10 to make it work, but 41.6, that's not between 1 and 10. We've exceeded the upper bound. So the number in between, and we can always find it. In this case, it's 4.16. But what did we do? We made it gigantic, right? It got bigger and bigger and bigger to 4.16. That means we need to make this small. And we do that with a negative exponent this time. And yeah, good call, Echo. This one will come out as -3 altogether. So that's the name of the game for scientific notation. Again, if this was a quiz problem or exam problem, I'd possibly want to double check this. There'll be time for exams to do this kind of work. 4.6 times 10 power 3, definitely not right. We want a small number. If we throw in that negative sign, that's really dividing by 1,000. Recall 10 power -3 really means 1 over 10 to the power +3. And if you work that out, that's just 1,000. So what happened on this one altogether? If you take 0.00416 and rewrite it as 4.16, you've shifted the decimal 1, 2, 3 spots, 3 units. Right. Units works, but I think the more standard thing to say is places for place value. Let me correct it to that. I think that's going to make this flow better if we say 3 places. We went 3 places right. We made the number really big. So we counteract it, shrink it essentially by putting in a negative exponent. So we put in -3 on this one. And that's the directionality mismatch. If you go to the right, you're making things big. So you negate it by putting in a negative sign to shrink it back down to its true size. If you took something big and you made it small, well, you moved it to the left, but you increase the size, bringing it back to the true number with a positive exponent. So these are the two directions we'll look into. We'll be doing more when we come back next class. Find out part C, do some arithmetic with scientific notation. It'll come up later on in these notes. But so far, this is the warm-up topic for this section. Just about every single section has something along these lines. Well, any last questions at all, folks, about the refresher on scientific notation so far? Okay, we'll end class here. If any questions come up, don't hesitate to ask. I'll be happy to help out. And I'll be returning your graded quizzes through the Canvas system once I get them graded on Friday. But have a great night, folks. We'll be right back here when we come back on Monday.
Thank you.
You bet. Thanks for your hard work, folks.